today's lesson is multiplying a binomial by a binomial. As usual, there is a video guide to go along with this lesson. If you have not printed the video guide yet, go ahead and pause the video, print the video guide, and then come back and join us for the lesson. So we are multiplying a binomial by a binomial. Before we go ahead and do some examples together, let's define what a binomial is, and then we'll list out the steps that we need to follow today, and then we'll do some examples together. So first we need to know what a binomial actually is. So let's start with the prefix bi. We talked about a monomial last time and how monomial comes from mono, which means one, and nomial is going with terms. So a monomial is one term. All right, so when we're talking about a binomial, bi is the prefix for two. So bi means two, so a binomial is two terms. So essentially what we're doing is we're multiplying two terms by two terms. All right, we're going to go over how to do that with about 5 steps. All right, so let's take a look at those 5 steps. Our first step is that we are going to multiply the first term to both terms in the second parenthesis. So multiply the first term to both terms in the second set of parentheses. You'll notice today that we're going to have a lot of parallels to the distributive property. Essentially what we're doing is the distributive property twice, all right? So we're going to multiply the first term to both terms in the second set of parentheses. Our next step is to multiply the second term to both terms inside the second set of parentheses. Now, the next 2 steps are going to be reminders for you. It's very similar to what we did last week when we took a monomial times a polynomial. The same rules apply for binomial times a binomial. All right, so that next step is make sure when you're doing that multiplication to multiply the whole numbers, those coefficients. Remember, coefficients are the numbers in front of the variable. So you're going to multiply the numbers in front of the variables. And then for our like terms, okay, remember like terms have the, or like variables, I guess I should say. So when you have like variables, you will add the exponents. All right, so that's our next step, our next rule that we need to follow. So when you're doing the multiplication, okay, when you're multiplying that first term and then you're multiplying by that second term, make sure you multiply the whole numbers and then go ahead and add the exponents. All right, and then last step, our 5th step, E, last thing we want to talk about, is we are going to have to combine like terms. Now, again, this part is review for you, but let's talk about like terms. Remember, like terms have to have the exact same variable. Nothing can be different. All right, so obviously x and y are different from each other, but you also have to notice that like terms would be just x, like 7x minus 5x. Those are like terms, okay? Really quick, just so you know what I'm talking about, if we had 7x squared minus 5x, these are not like terms, okay? Not like terms. The x squared has an exponent of 2. The x, there's no exponent written, but remember that means there's an exponent of 1. They just don't put it in. That is different. They are not exactly the same. They don't have the exact same exponent. This actually means 7 times x, where 5x just means 5 times x. The x's are different. There's 2 here, there's only 1 there. That's different enough where these are not like terms. All right, so be careful of that. like terms, exact same letter, unlike terms, same letter, different exponent, not alike, okay? All right, we're gonna go ahead and do a couple examples together. For problem number 3, we have 3x minus 7 in parentheses, and then right next to it we have a 3x plus 9 in parentheses. Now the way that we know that this is multiplication is because those parentheses are right next to each other. There's nothing separating them. If this was an addition problem, they would put an addition sign. If it was subtraction, they put subtraction. If it was division, they put division. Anytime they leave out the operation between two sets of parentheses, or remember a number and a letter, it means multiplication. So we are multiplying these two sets of parentheses together. So it's a binomial, 1, 2 terms, times a binomial, 1, 2 terms. All right, so our first step says that we need to multiply our first term, which is 3x, and we need to multiply it to both terms in the second set of parentheses. Okay, so remember I told you this is going to look very similar to the distributive property. Essentially, we are doing the distributive property twice. All right, we're going to distribute that 3x, and then we're going to distribute the minus 7. So let's start with the 3x. Our rule says that we need to make sure that we multiply whole numbers, so 3 times 3 gives us 9. We also need to add exponents. If there's no exponent for that x, there is a 1, they just don't write it. So that means there's a 1 over here as well, they just didn't write it. Add the exponents together. 1 plus 1 is 2. We also need to take that first term and multiply it to the second term in that set of parentheses. So we're going to take 3x times 9. Well, 3 times 9 is 27. It's a positive 27, so I'll put an addition sign to separate my terms. And then x to the first, there is no x here. So I just bring down x. Stays the same. That's our first part. Next, we need to go ahead and multiply the second term to both terms in the second set of parentheses. So again, we're doing that distributive property. Okay, so we're going to multiply. This is a minus 7, so it's like we're multiplying by negative 7. All right, so we're going to take negative 7 times 3x. Multiply the whole numbers. Negative 7 times 3 is negative 21, so I'll put minus 21. There is no x with the 7, but there is with the 3, so we just bring the x down. There's no exponents to add together. And lastly, we need to multiply negative 7 times 9. So negative 7 times positive 9 is negative 63. Okay, so we've done all of our steps except for combining like terms. So I need to go ahead and combine my like terms. If I look here, I have an x squared, an x, and then this doesn't have a variable. So remember, if we talked what we talked about for the combining like terms, they have to have the exact same letter. X squared is different from x, so this is not a like term. But 27x and minus 21x, those are like terms. They have the same letter. So I can go ahead and combine those. My 9x squared is going to stay the same. 27x minus 21x is positive 6x. The minus 63 stays the same. This is our answer. 9x squared plus 6x minus 63 is the solution. All right, I can't change this. There's nothing else I can combine, so we are done. Let's take a look at number 4. I have negative k plus 8 times, remember there's nothing in between them, so that means multiplication, so times 10k plus 1. Our first step is to multiply by the first term to both terms inside the second set of parentheses. Now, this is a negative k, all right? There is no number in front of it, but remember, there's a 1, they just don't write it. So we're going to go ahead and put that 1 right in, so we don't forget about it. So what I'm going to do is multiply my whole numbers, negative 1 times 10. That gives me negative 10. For the letters, remember we have to add the exponents. So this is k to the first, this is k to the first. 1 plus 1 gives me k to the second. After that, I need to multiply negative 1k times 1. Well, negative 1 times 1 is just negative 1. Our first term has a k, this last term does not, so we just put k. There's nothing to add to it. We don't have to add exponents there. Next, distributive property again, but this time with the positive 8. So we're going to multiply both of these by positive 8. So positive 8 times positive 10k gives me a positive 80k. And then positive 8 times positive 1 is positive 8. Again, here I didn't have to add exponents for the variables because I only had the k here, and these, the 8 and the 1, didn't have variables, so we don't have to worry about that. So we've done our multiplication. That last step is to combine like terms. So we need to look for like terms. I have a k squared, a k, and just a number. So k squared is different from k, so that's not a like term. But my minus 1k and my 80k are like terms, so I can combine those together. So negative 10k squared stays the same. Negative 1k and positive 80k. Different signs we subtract. Make sure you look at this as like a negative 1. Don't forget that that minus sign is there. So 80 minus 1 is 79k, and it will be positive because you keep the sign of the bigger number. And then my plus 8 just comes down. So our solution for problem number 4 is negative 10k squared plus 79k plus 8. For problem number 5, we have negative 4n plus 1, and we're multiplying that by negative 3n minus 9. So first thing we need to do is take the first term and multiply it to both terms inside the second set of parentheses. So we're going to have negative 4n times negative 3n. Multiply the whole numbers. Negative 4 times negative 3 is positive 12. From there, we add the exponents. Remember, this is a 1, this is a 1. 1 plus 1 gives me n squared. All right, after that, we need to multiply negative 4n times the negative 9. So multiply the whole numbers. Negative 4 times negative 9 is positive 36. And we just bring down the n because there's nothing to add to it. All right, so that's multiplying by the first term. For the second term, we're going to take the positive 1 and multiply it to both terms in the second set of parentheses. So 1 times negative 3n, 1 times negative 3 is negative 3. I only have the 1n, so the n stays the same. Okay, there's nothing to add to it. After that, I need to multiply positive 1 times negative 9. Well, 1 times negative 9 is negative 9. There's no letter involved, so it's just negative 9. After that, our last step is to combine those like terms right here. Remember, 12n squared is not a like term because it has the exponent of 2. So that will stay the same, 12n squared. 36n and minus 3n. When I combine those, I subtract. I'm going to get positive 33. Keep your letter the same. Okay, the only time you add exponents is when you're multiplying. You don't add the exponents when you're adding and subtracting. The minus 9 stays the same because it's not a like term. And this is our answer, 12n squared plus 33n minus 9. Let's take a look at problem number 6. Again, our first step, do that distributive property with the first term in the first set of parentheses. So we're going to multiply by negative 8v. So we're taking negative 8v times positive 3v. Multiply the whole numbers. Negative 8 times positive 3 is negative 24. For the variables, add the exponents. So 1 plus 1 gives me v to the second power, v squared. So negative 24v squared. From there, I need to multiply negative 8v times negative 8. Multiply the whole numbers. Negative 8 times negative 8 is positive 64. I have a v in my first term, but not in my second term, so it just stays the same, v. All right, after this, we need to multiply by the second term to to both numbers in the second set of parentheses. So let's start with 6 times 3b, multiply the whole numbers. 6 times 3 is positive 18. The 6 doesn't have a v, but the 3 does, so we just bring it down. Nothing to add to it. And now we just multiply 6 times the minus 8. So 6 times negative 8 is negative 48. There are no letters in either term, so we just leave it as minus 48. Last step, combine those like terms. V squared, v, and no letter. Means that these two middle terms will be combined. The v squared is not a like term because it has the exponent of 2. So negative 24v squared stays the same. And then we combine these. 64 plus 18v, 64v plus 18v, is positive 82v. Okay, add the two together, keep your letter the same. You only add exponents when you're multiplying. And the minus 48 comes down. So your solution for problem number 6 is negative 24v squared plus 82v minus 48. At this time, go ahead and pause the video, work on problems 7 and 8 on your own, and then come back to the video and check your answer with me. Okay, for problem number 7, we have 4k plus 8, and we're multiplying that by negative 1k plus 8. The first thing I did was go ahead and put that 1 by the negative k. It just helps me remember that I'm multiplying by negative 1. So from there I multiplied 4k times negative 1k. I got negative 4k squared. Don't forget to add the exponents. And then I took 4k times the positive 8. I got positive 32k. From there I multiplied the positive 8 times negative 1k. I got negative 8k. And then I took positive 8 times positive 8 and got positive 64. My last step here was to go ahead and combine my like terms, the negative 32k and the positive 32k and the negative 8k. I got 24k when I combined those. So my answer was negative 4k squared plus 24k plus 64. For problem number 8, I multiplied the negative 3x to both terms in the second set of parentheses. So negative 3x times negative 3x gave me positive 9x squared. After that, I took negative 3x and multiplied it times negative 3. That gave me positive 9x. Then I multiplied the negative 7 to both terms in the second set of parentheses. So I took negative 7 times negative 3x. That gave me positive 21x. And then negative 7 times negative 3 is positive 21. Last step here as well is to go ahead and combine those like terms. 9x plus 21x gave me 30x. So my answer is 9x squared plus 30x plus 21. And that's the end of our lesson on multiplying a binomial by a binomial.